Hi, this is the video for confidence intervals for a population mean. In this video we'll discuss why we do a confidence interval for a sample mean, what we need to for a sample estimate, right? Why we get a confidence interval for the population mean using a sample estimate, what we need to calculate that, how do we interpret a margin of error, and how do we interpret the confidence interval for the mean. Well, the goal is to estimate a population mean using a sample, right? We will never be able to observe the population. We will only deal with sample data. But sample data has sampling error. And if you remember from previous videos or the introduction to confidence interval video, we discussed that the sample is not likely to look exactly like the population due to sampling error, right? Just by chance. And that's why we use statistical theory to control for this sampling error. In order to calculate a confidence interval for a mean, you need a sample mean, a sample standard deviation, a sample size, and a t-distribution table, right? Critical values. Now, when we do this in Excel, you can get that t from using an Excel function. But if you don't have Excel and you're doing this by hand, you would need a t-distribution table like the ones you used in your basic stats class. And you also need an idea of how accurate you want to be, how accurate you want your confidence interval to be. You want to be 90% sure of where the population parameter lies, or 95% sure, or 99% sure of where the population parameter falls. Once you have that, the formula really is simple. It is just the sample mean, right, plus or minus a critical value of t, right, for two tails for the desired confidence, and n-1 degrees of freedom. We'll discuss that in a little bit. Is the sample standard deviation, and that is divided by the square root of the sample size. So really, it's calculating a confidence interval for a mean is pretty simple. Now the hard part is interpreting. The harder part, I should say, it's interpreting what a confidence interval mean, and to understand that you have to know what a margin of error is and what it means. So a margin of error is this part of the formula, and it tells you how far you may be from the population mean for the degree of confidence that you chose, right? You may be 0.3 points away from the population mean, and you're 95% sure of that. That's the way you would interpret a margin of error. It is how far you may be from the population parameter given your confidence level. So let's walk through an example. Suppose that we have a sample of 10 CHHS students. This is a random sample, and we want to know, based on this sample, right, what is the GPA for the population? Right. We know the sample GPA. Let's say for these students we calculated the average GPA and we got a sample mean of 3.1. So for this sample, the mean is 3.1. Now, what is the GPA for the population? We don't know, right? And we don't know how large the sampling error is for this sample. So the only way for us to have an estimate of the population, we need to construct a confidence interval. The sample standard deviation in this example is 0.3, and the sample size is 10. Right? And suppose we want to be 95% confident in our estimate. Okay, so we already have here the sample mean, the sample standard deviation, and n, the sample size. Now we need the critical value t for this level of confidence. And to obtain that, you would go to a two-tailed t-distribution, right, table. and you would look for the degrees of freedom that you need. The degrees of freedom are given by n minus 1. That's the number of observations minus 1. In this case, we had 10 observations, so the degrees of n minus 1 equals 9, right? So 9 degrees of freedom. This is the row that we would be looking at. This is the sampling distribution of the t statistic, right? For those degrees of freedom. And we will look at 0.05 probability in both tails, right? So you pick the probability that gives you 1 minus the confidence you want. In this case, we want 95% confidence. So we would pick 0.05 in each tail. 1 minus the confidence equals 0.05, right? So the number that is the t value, the critical value that corresponds to this probability and these degrees of freedom is 2.62. That is how you would get the critical t value to plug in your formula here. Now, thankfully, Excel can get this number for us. If we plug in the probability and the degrees of freedom, Excel can actually give us that to us, and I'll show you how to do that in another video. Okay, so continuing with our example, we have that our standard deviation was 0.03, our mean was 3.1, the t that we got from the table is 2.262, and then n was 10, right? The sample size was 10. This part of the formula gives us the margin of error, which in this case is 0.21. And it means that our estimate we are 95% sure, right? We are 95% sure that the population mean lies within 2.1 points of our sample estimate, right? We're 95% sure that we may be 2.1 away from the population mean. Okay. Now, when we add and subtract the margin of error from the sample mean, we have our confidence interval. This is the lower level and the upper level. So, to interpret this, we can say that we are 95% sure that the population mean is between 2.89 and 3.31. Okay, how do we know that? Well, this is our sample estimate, the 3.1, and then we're adding the margin of error here, right? Now, we don't know where the population mean is. We never will, right? But we're 95% sure, right? And this is because of the central limit theorem. We're 95% sure that the population mean falls within these two numbers, between 2.89 and 2.31. Right? So the margin of error is telling us that our estimate is likely to be 2.1 away from the mean, either higher or lower, and that's why we're 95% sure that the population mean lies between these two values. So there are two things that you can do to have a smaller margin of error. One of those is reduce the confidence level you want, right? But you may not want to do that, right? If you really want to be accurate, you don't want to reduce this too much. The other one that you can have more control of is the sample size. The larger the sample size, the smaller the margin of error will be. So in summary, to calculate the confidence intervals for a mean, we need a sample mean, sample size, sample standard deviation, and a critical value of t associated with the required degree of confidence and n-1 degrees of freedom. This is the formula you would use, right? This part here is the margin of error, and that tells you how far your sample estimate may be from the population mean, right? And then you would interpret your confidence interval, right, in the following manner, right? We are X% confident that the population mean is between this and this, right? In the following video, I'm going to show you how to calculate a confidence interval for the mean using Excel. Enjoy.